So now what I'm going to explain is the connection between the increasing and decreasing function and the slope of the equation of the curve. Okay, I have chosen the x-axis, y-axis, and now let me take a curve which is increasing up to some point and then starts decreasing after some point. Let me call these points as A and the peak point as B and the down point as C. That is, the curve is increasing from A to B, reaches a maximum at B and decreases from B to C. Now what I'm going to do is choose a point in between in the increasing interval A to B and see what is going to be dy by dx, for that whether it is going to be positive or negative. And also we are going to choose a tangent at some point in between B and C, draw the tangent and find what is going to be the slope of that tangent or connect it with dy by dx and see whether it is positive or negative. Okay, now I'm going to draw some random, choose a random point and draw a tangent here and here also. Now I'm going to draw a tangent. Okay, now if I look at this tangent makes an angle theta and it is very clear that it is an acute angle. Whereas this makes an angle alpha say and it is very clear that it is obtuse. And what do we know about the connection between tan theta, dy by dx and the gradient? Of course, we know that dy by dx at any point of the graph is nothing but the gradient of the tangent at that point. Therefore, dy by dx equal to m equal to tan theta for the point, say call it E. And let me call this point as F. At E, dy by dx equal to m equal to tan theta. And since theta is acute and since we know that tan of an acute angle is positive, the dy by dx of all the points from A to B will turn out to be positive. And what will happen to the dy by dx of all the points between B and C? Dy by dx at the point F is going to be, let me call it m dash, is going to be tan of alpha, and alpha being an obtuse angle, it is going to turn out to be a negative quantity. So it is now very clear that when the graph is increasing, dy by dx will be positive, and when the graph is decreasing, dy by dx will be negative. That is why we say that in an increasing interval, the gradient or dy by dx or the first derivative will be positive, and when the graph is decreasing in a particular interval, then we say that the gradient or dy by dx, the derivative of the equation of the function, will be negative at the point for all points in between B and C. For all points between A and B, dy by dx will be positive. For all points between B and C, dy by dx will be negative. And so what happens at B? See, when a function is increasing and it is now going to decrease, obviously that means it should have reached a maximum point, and that maximum point is B in this case. That is why in first derivative test we call this first derivative test, that is deciding about the local maxima or minima using dy by dx. If the dy by dx changes from negative to positive, we say that it is a point of local minimum, whereas if it changes from positive to negative, we call that it is a point of local maximum. Now in this case, I have not shown how the graph will reach a minimum. For that, maybe we can extend like this and go up to this, and here say call this point as say D, and D we are able to see that from B to D, dy by dx will be negative. From D to say some other, I have already taken D, E, F, G. Okay, from D to G it will be positive. Therefore, when it is changing from negative to positive, it has to reach a minimum. That is why we say that when dy by dx changes from negative to positive, the point at which the minimum happens is called the local minima, and the other way around, when the graph changes from, that is dy by dx changes from positive to negative, it is changing from increasing to decreasing function, and we call the point at which it reaches its maximum as a local maximum. I hope this gives a clear idea about